Symmetrical properties of circle practices. We are going to use some of the textbook questions as your homework practices. So inside this question number 4, in the diagram, O is the center of the circle, AB is equals to BC, and it's 40 cm. Now let's take a look. If I have AB to be of the same length as BC, what does that tells me about the line ON and ON? Using the symmetrical property number 2, chords that are equidistant from the center of the circle have the same length. So that means ON equals to ON. And ON is 9 cm. Therefore, ON will be also 9 cm. So part A of the answer, ON is equals to 9 cm. Next, we know that this is from the center of circle. I have a 90 degree here. What does that tells me about the line AB? Now, M will be the midpoint. So instead of 40 cm, we will have BM to be 20 cm. And they asked me to find the radius of the circle. Where can I draw to find the radius of the circle? I can add in O to B. In that case, I will have the right angle triangle BMO. And how can I find the radius of the circle? We can use the Pythagoras Theorem. Radius will be equals to square root of 20 square plus 9 square. And that gives us 21.932 in 5 sig feet and 21.9 correct to 3 second figures, cm. Have you gotten the answer? Next question, question number 5. AB and CD are parallel chords of the circle. AB is 5 cm and CD is 4 cm. The radius of the circle is 3 cm. How can I find the perpendicular distance between the two chords? Now let's try to find something about the radius. Where can I draw the radius of the circle? I can draw maybe O to B. This is 3 cm. If that's the case, what can I form? Maybe I can try to draw the perpendicular distance from O to B. Perpendicular distance, right? So it will be 90 degrees. And I can also extend a perpendicular distance here, which is also 90 degrees, such that they are parallel to each other. And I can also have another radius over here. Three cm. If that's the case, I form two right angle triangles. Let's take a look at the first one. BA will now be instead cut into two parts. So I will have the midpoint over here. This is 2.5 cm using symmetrical property number 1 because they bisect. This perpendicular distance bisect AB into 2 equal halves. Similarly, I will have this line over here. It will cut CD now into 2 equal parts. So now this one will change to 2 cm. So in order to find the perpendicular distance between the two chords, let's find each of the smaller distance over here. For my first triangle, I have B. Let's call this point X. To O, this is 2.5 cm. and 3, what can we find? We can find XO. So XO will be equals to square root 3 square minus 2.5 square. And that gives us 1.6583. Now, our next triangle, we can have the one over here, D, O, and maybe we call this Y. So this is now 2 cm, the radius is 3. We can find OY. Square root of 3 square minus 2 square. And that gives me 2.236. So the perpendicular distance between these two chords will now be, adding the two distance up, (1.6583 plus 2.236). And that gives me 3.8943, rounding it off. 3.89 cm. Have you gotten the answer? Next question, question number 6. The diagram shows two circles with common center O. The radii are 25 cm, that means the shorter one, and 29 cm respectively. How can I draw the radius into these circles? So maybe I can draw O to C as the first radius, the smaller radius 25 cm, and maybe O to A as the larger radius 29 cm. Question tells me that BC is 30 cm. Notice we have a 90-degree down here. That means OM bisect BC from 30 cm, cut it into two equal halves, so MC will now be 15 cm. So let's draw out our first triangle over here. M to C is 15, 25. And we also know that the next line, O to M, is also perpendicular to AD. That means M to D will also be cut into two equal portions. Question A. Is AB equals to CD? How can I find AB? So let's start off our question for part A. AB can be found by taking AM, subtracting BM, the smaller portion over here. Okay. And then we will be able to get AB. But at the same time, with the symmetrical properties of the circle, AB is actually the same as equals to MD. And we know that BM is the same as MC. What does that leave us? If I have MD minus BC, that gives me CD. So is AB equals to CD? Yes, shown. Part B. Find the length of OM. In my understanding of the question, we have already drawn this right angle triangle over here. And what can we use to find OM? We can use the Pythagoras Theorem. square root of 25 square minus 15 square. That gives me a length of 20 cm. So OM is now 20. Part 2. How am I going to find AD? AD is made up of A to M to O and a radius of 29 cm. I found OM to be 20. What can I find first before I find AD? Oh, I can find AM first. So how do I find AM? I can use a right angle triangle, the Pythagoras Theorem. 29 square minus 20 square. I get the length of 21 cm. To get AD, as it cuts them into two equal parts, so AD will be 21 times 2, that gives me 42 cm. Next, let's find out what is CD. Oh, we know that CD is made up of AM minus BM in part A. So CD is now AM, which is 21 cm, minus BM. BM, which is the smaller portion over here, it's also 15 cm. And hence I get the answer CD to be 6 cm. Have you gotten the answer? Question number 7. The chord AB is perpendicular to the diameter CD of the circle, center O. Now take note, AB is perpendicular to CD, so I will have a 90 degree over here. AB is 70 cm. Since CD is perpendicular to it and it passes through the center of the circle, what will happen to AB? Well, it will be cut into two equal parts. So I will have AE to be 35 cm and EB to be 35 cm. Now the question tells me that CE is 25. Find the radius of the circle. Where do I draw to find the radius of the circle? I know that, the radius of circle can be O to A. Do we have sufficient information? Where else is the radius of a circle? Let's take a look. OA is the radius. We shall let it be the letter R, representing the radius. But this radius can also turn and become C to O. So CO is also the radius. If CO is the radius, then what is O to E? If CO is the radius R, CE is 25, so O to E will be R minus 25. Let us make a quick sketch of this triangle. It's a right angle triangle, radius R, length 35, and this length OE over here will be R minus 25. In this case, we will have to try to solve a quadratic equation in terms of R. So let R be the radius. In a right angle triangle, we know that the Pythagoras Theorem exists. Okay, so triangle OAE will satisfy the Pythagoras Theorem, given that hypotenuse square equals to 35 square plus r minus 25 holding square. Now we're going to expand this. So I'll get 35 squared to be 1225. Please take note, usually students will give me r minus 25 square is r square plus 25 holding square. That is not true. It's r minus 25 times r minus 25. So remember to do a proper expansion for this part. So I'll get r square minus 25r minus 25r plus 25 times 25, 625. And the rest stays the same. Let us try to simplify this equation. Take note, there is r squared on both sides. So if you were to shift them and cancel away, and I'm left with 0 equals to 1225 minus 50r plus 625. Shifting the terms around, I'll get 50r to be equals to 1225 plus 625. That gives me 1850. And therefore r will be 37 cm. Now I found the answer. R is 37 cm. And OE will be 37 minus 25. OE will be 12 cm. Now let's find part B. Calculate the area of triangle OAB. OAB is actually has a length of 70 cm and a height of OE 12 cm. So therefore area of triangle will be half times base times height. That gives me the answer 420 cm squared. Have you gotten the answer? Next question, question number 10. The cross-section of the tunnel is in the form of a major segment, ABT. So we are looking at the major segment, which is this whole portion over here. Okay. The perpendicular distance from the highest point T to the chord BD is 8 meters. Find the radius of the cross-section of the tunnel. Let's take a look at the following question, and we should try to draw some information in. So I know that this whole thing is 8 meters. They ask us to find the radius of the cross-section. Let me draw in a radius. So let this radius be R. I know that there will be a 90 degree over here. If this is the radius, where else can be the radius? Well, OT can also be the radius. So if this whole length here is 8 meters, and OT is R, the radius, what is the expression for this portion? We can get 8 minus R. Now I know that AB is perpendicular to this length over here, so hence AB will be cut into 2 equal portions, and I have one small part over here to be 4 meters. Let us try to draw out this triangle again. I will have R radius, length 8 minus R, and the sub part here to be 4 meters. Now notice this is a right angle triangle. What can we form? We can use the Pythagoras Theorem to form a quadratic equation. So in this case, hypotenuse square OB equals to side 1 square plus the next side square. Be careful of the expansion. R square is equals to 16 plus, now students always try to make mistakes down here. Let's prevent this by writing it as 8 minus R times 8 minus R. It's repeated. So expanding this portion over here, we will get 64 minus 8R plus R squared. The rest stays the same. So R squared equals to 16 plus whichever. Let's take a look at the equation. We notice that we have R squared and R squared on both sides. So we can cancel them out. And we'll have no more R squared. So let's simplify our equation. I'm left with 0 equals to 16 plus 64, 80 minus 16R. So shifting the terms over, I got 16R to be equals to 80, R to be equals to 5 cm. Therefore, the radius of the cross section of the tunnel is 5 meters. That's the end of all the questions for now. Okay, we'll move on to the next part of the chapter.